So let's say here we are given a point, let's name it point A, and we are also given a vector B1, and we are drawing a line passing through A and parallel to B1. Let's write the equation of this line first. Equation is written as R is equal to A1 vector. A1 is the position vector of the point A, and plus the lambda time B1 vector. Okay, so B1 is given, A1 is given. So this is a unique line is drawn. We want to draw one more line, and let's say there is another line which is passing like this, and this should also pass through a given point. Let's say that point is B there. Okay, this point is B. Its position vector, let's say A2, and it is parallel, and a parallel vector to this line should be given. The parallel vector can be given anywhere, as I said, just it gives you the sense of direction in passing through this point and parallel like this, no? So we, to understand it a little better, what we are writing is we are starting our parallel vector at this point, and we want to draw a vector. This is our vector, say B2. Let's name this vector B2. And this point B is its position vector is A2. So our line, white line, I'm writing in white line can be given as A2 vector plus mu time B2 vector. Does it make sense? Yes. Now, anywhere in 3 dimension, usually will be given in your lines in this forms. I mean, your first line is related with vector b1, second line is related with b2. And what I want to show here is this angle. If I could find the angle between b1 and b2, let me write this by theta. This angle is same as this angle. As you can see the parallel lines, and then you can say, well, these are corresponding. So it makes sense, like angle between two lines is same as angle between two vectors. We would use the formula for the dot product to find angle between these two lines, that says A1, if you have two vectors, let's say here in case of this B1, B2, right? So we can say B1 dot B2, B1 vector dot B2 vector should be same as magnitude of B1 vector, magnitude of V2 vector, and cos theta. This formula give you that theta, and you can write it actually down there. You can say cos of theta should be B1 vector dot B2 vector divided by magnitude of B1 vector times B2 magnitude of B2 vector. As you see, this angle is theta. If this is acute angle, angle between the line, let's talk. So if this is acute, so that is going to be obtuse angle. And cos of acute angle is always positive. So we want to find this acute angle. For that reason, we can put a mod sign over there. So these are the two lines, and we want to find angle between these two lines. Simply, the first line is passing through this point. The first one is the point and parallel to this vector. And the second line is passing through this point and parallel to this vector. So what we want to do is we want to take the vector b1 and b2 and find angle between these two vectors. So you can simply write cos theta. Cos theta would be b1 is 3i cap plus 2j cap plus 6k cap dot, you want to multiply this with I cap plus 2j cap plus 2k cap and divided by mod of b1. Mod of b1 would be square of 3, which is 9, square of 2, which is 4, square of 6, 36, times, multiply this also, 1 plus 4 plus 4, 2 square, 2 square. So to find dot product, we know I dot I is equal to 1. And I dot j and I dot k is 0. So just we need to multiply I with I, j with j, and k with k. So 3 into 1. So that is going to be 3 into 1 is 3. Plus, now you are going to multiply this with this. So 2 into 2 is 4, j with j. Plus k vector, k component of the vector is going to be multiplied with k. 6 into 2 is 12 divided by, this is 49, square root of 49 should be 7, and square root of this is 9, square root of 9 is 3. Now you get cos theta is equal to 3 plus 4 is 7, 7 plus 12 is 19 divided by 21. This implies, you can, cos theta is 19 by 21, you can find theta from there. Or you can also write cos theta is equal to, sorry, theta is equal to, you can write theta is equal to cos inverse 19 divided by